Hello folks, welcome to this series of AWS services. Today we'll be talking about elastic load balancers or simply ELBs. Now before we go on and move about various types of ELBs which are there, features of ELBs, let's first talk about what is the relevance of ELBs. Now when you talk about scalable application, what we mean by scalable application is that if there is a demand arises, then you should be able to scale out your application. Scaling out means creating identical web servers or application servers which can process the requests from the clients. So think about a scenario where you have hosted a web application. Now your web application has gone viral. So a lot of requests have started powering in your web application. Now requests are coming so frequently that your server is not able to process all of them. In that case, you might want to create multiple servers of the same type and divide the work which is coming in to all those servers. Now this kind of scaling is called scale out, and the opposite of this is like when there is a less demand, you might want to terminate few of your instances. That's called scale in, and this kind of scaling is called horizontal scaling. There is another kind of scaling which is called vertical scaling, where if the demand increases, you can upgrade your existing system and bring in a higher configuration of your system. So suppose if it is using 10 virtual CPU, you can scale up to make it something like 50 virtual CPUs with enhanced RAM or enhanced CPU capacity. That kind of scaling is called vertical scaling, and when you enhance the capabilities, it is called scale up. When you downgrade the capabilities, it is called scale down. So when you scale up and scale down in vertical scaling, it is okay, but how do you divide the traffic across multiple servers in case of scale out? So when you've got multiple identical servers doing the same thing, you need to have a mechanism where you can distribute the traffic across those servers so that each server can process those requests and give back the response. So AWS provides a service which is called Elastic Load Balancer that takes a request of the client from one end and distributes the traffic across multiple servers on the other hand. So ELB is a fully managed web service, which means AWS takes care of features like high availability, scalability, security, etc. So from a web developer's perspective, you just need to create the load balancer and provide it proper configuration. So few basic things first. Elastic load balancers work within a region and within a specific VPC, virtual private cloud. If you don't have your own VPC, you can use default VPC, but you have to create it within a VPC. Elastic load balancers cannot distribute the traffic across the region. They would be within a region only. If you want to do the load balancing across the region, then you may go for Route 53, which provides a similar kind of service. So ELBs, though they are within a particular region, they can span across availability zones, which means you can attach instances, attach the servers which needs the traffic coming from the ELBs from different availability zones within the same region. So while creating ELBs, you don't have to specify availability zone, but you do have to specify the region in which you are creating them. To configure Elastic Load Balancer, you configure it using listeners. Now ELBs would have two ends of the listener. On one listener, it is talking to the clients, which could be internet users. On the other hand, it would be talking to the servers which are attached to it. So on the both end, it has to configure the listener, and listener is nothing but a set of protocol and port number. So depending on what kind of load balancer you are using, the protocol etc. could be different. For example, application load balancer works with HTTP and HTTPS, whereas network load balancer works on layer 4 of OSI model. So using ports like TCP, etc. Now based on where your load balancer is located, there are two types of load balancer. One is called internet facing load balancer, which is directly dealing with the internet users. This kind of load balancer sits between the web servers and the internet clients. So the DNS name of the load balancers get resolved to public IPs of the instances attached to it. This we are talking about internet facing load balancer. Now your position of load balancer can also be between the web layer and application layer, for example in web applications, where the load balancer is also getting the request from the instances maybe somewhere in the web layer, and it is distributing the traffic across the application servers which lie in application layer. Now mostly these application servers would have only private IP addresses. They would not have public IP addresses. So this kind of load balancer is called internal load balancer. So in case of internal load balancer, the DNS name of the load balancer resolves to private IP addresses of its servers. So whether the DNS name of the ELB is resolvable to public IP or only private IP, it will be called either internet facing load balancer or internal load balancer. So other than this criteria of dividing a load balancer into multiple types, there are multiple load balancers provided by AWS based on its features. So we have got classic load balancer, we have got application load balancer, and we have got network load balancers. All these load balancers we'll talk about in a separate video. So what are the other features of load balancer? Now as we said, every time we go and use load balancer, it will take the request from a client, it could be internet user or it could be a web servers from web layers, and then it will divide the traffic to multiple instances, multiple EC2 instances. Now while distributing the traffic, it also keeps on checking the health of its clients where it is sending the traffic. So the instances which are registered with the load balancer to receive some kind of traffic, we'll call them registered instances from here onwards, and these registered instances health is being checked by Elastic Load Balancer constantly. So if a particular registered instance is down or maybe it's too busy to process any request, then load balancer can detect it and it can stop sending the traffic to those instances after marking it as unhealthy. It will still keep on checking the health of those unhealthy instances, and when they come up or when they become free to process the requests, then they can be marked as healthy by Elastic Load Balancers. So this kind of health check is done by ELBs by using various protocols, which we'll see when we go and talk about load balancers in a more detail. Now the feature of ELBs are cross-zone load balancing. So as we already discussed, that registered EC2 instances of a load balancer can come from multiple availability zones. So while distributing the traffic, should the load balancer divide the traffic based on how many number of availability zones are there, or should it divide the traffic based on how many number of instances are involved? So if you enable the cross-zone load balancing feature, then it will divide the whole traffic by number of instances which are involved, and based on that it will divide the whole traffic into various instances. Whereas if your cross-zone load balancing is disabled, then the traffic distribution happens based on the number of availability zones. So let's take an example. Suppose you have got two availability zones. In one of the availability zone there is one instance, in another availability zone there are 4 instances. So if your cross-zone load balancing is disabled, then the number of requests would be just bifurcated into two parts. 50% of the traffic would go to one availability zone having just one instance, and 50% of the traffic will go to the another availability zone which has got 4 number of instances, which may not be a very good option. So if you enable cross-zone load balancing, then irrespective of the availability zone, the request would be divided by number of instances and the traffic would be distributed equally across those instances. So in this case, if you enable cross-zone load balancing, then only 20% of the traffic will go to one availability zone having one instance, and another availability zone will get 80% of the traffic, distributing further 20% of the traffic to each EC2 instance. So this particular feature is always enabled in your application load balancer, but you might have to do it manually in your classic load balancers. So we'll talk about these various kind of load balancer in the next video. See you soon in the next video. Thank you for watching.